supposed to record all this. Damn.
Oh, it's
It's
alright.
supposed to start automatically, but it didn't. Um,
Mhm.
so I apologize to whoever for not recording. Well, but a lot of it was just a general discussion, so actually it's not so bad. So the previous stuff, there's going to be a short recording today, but I'll just repeat the two things that I said really quickly. It's supposed to start automatically, but they didn't set it up. So I was told to watch it, but I forgot. Um, so I'll just repeat those two things quickly. A transformation is a one-to-one mapping of the plane onto itself, and an isometry is a transformation that preserves distance. So how do you measure in GeoGebra? So here's GeoGebra, and I'll get, you know what? I don't need a new window. I'll use your triangle. So you can see that?
No, I can't.
You can't. Okay. I didn't share my screen. Oh, yeah. Hello. Share screen. Share entire screen. Okay. Now, can you see that?
Yes.
Okay. So suppose I want to measure some angles. Right up here, this is the tool. So I'll go through this really quickly. And so, yeah. So I select 3 points, but we may have done this last time. But I'm going to select 3 points, and I want you to tell me what's going on. Okay? Here's
Okay.
1, here's 2,
Yeah.
here's 3.
Measure the angle outside.
Right. So how could I get it to measure the angle inside?
Um, yeah, I actually don't know.
Okay. Um, watch.
You just go the opposite way?
Yes.
Okay. Okay.
So what's the convention? Can you tell me the convention on this?
Um, yes.
And speak a little louder so I can hear you. Or turn
Okay.
your.
It seems like going clockwise gives you the the interior angle.
Okay. I went to get the interior angle, I went here, and then
Yes.
here, and then here.
Yes.
So which direction is
Like
that?
that's clockwise.
It's from here to here, here to here.
Oh. Oh, okay. Yeah, it's counterclockwise, sorry.
It's counterclockwise, yeah. And does that remind you of anything in trigonometry?
Yeah, counterclockwise rotations are considered positive.
That's right.
Yeah.
So that's the convention that's used. If so, you have to be careful if you're measuring an angle. Um, Counterclockwise is positive, the other way is negative. Clockwise is negative. If you want to measure a distance or a length, that's the only other one. You can see the others. Then, as it says, and it's in centimeters. So select 2 points, a segment, a polygon, or a circle. You can select lots of things. But if you select this and then you select this, and this time the order doesn't matter. Uh, and it tells you that AC is, and the reason it says AC equals is probably because if I select the segment here and I do the object properties, uh, let's see, AC. Oh, boy, I don't know why it did that. There's text. Uh, Usually it doesn't do that. Usually it just gives you the number. Let me try another one. That's weird. I've never seen that before. That's what happens with software. Let me try that again. I select 2 points, a segment, So I thought I just selected 2 points. Let's see, this point, just like, see the angle, it just gave me the number. It didn't say angle so-and-so equals something. It just gave me the number. No, but now it's giving me this. So probably, I think I know why. Because in options, advanced, I probably selected, yeah, the auxiliary object. Huh. And now it's saying it's making them text, probably because I have the auxiliary object checked, which I shouldn't have. That's probably why it did that. That's my guess. So if I uncheck that, let's see if that makes sense. I'm going to try BC now. BA. No. Okay. Help me figure that out for homework. I'm not sure what's going on. What I remember from previous times is just, it doesn't say AC equals, it just gives me the number right here. So I'm not sure.
Okay.
I'll have to play with that, but I don't want to waste our time. So those are the measuring things. There's a tutorial that I'll give you a link for, but you probably don't need it. Then what does it mean? One of the things that's really important in transformations is for a measurement or a relationship to be preserved under a transformation. For example, so preserved is the key word. What would it mean for, well, we've already used it for isometry. Isometry preserves distance. So
Yes.
what would that mean? Flesh that out for me
Well,
in a sentence.
under, like, say you have a triangle, so under any sort of like isometry, say like a translation, then a side length of the triangle, like say like AB, will be the same in A prime B prime.
Right. So that's what preserved means. That's for a measurement or an attribute. I came up with this distinction, actually. I don't see it anywhere else. But we also talk about relationships being preserved. For example, parallel. So we could say that translation preserves parallelism. And what that, or rotation, a better example is rotation. Rotation preserves parallels. That does not mean that the image is parallel to the pre-image. What it means is that if you have two lines in the pre-image that are parallel, then the image lines will also be parallel. So that relationship of parallelism is preserved. Make sense?
Yes. Yeah.
Okay, so there are two types of things that can be preserved. For homework, I'll give you some work on figuring out what's preserved and what's not under the various isometries the three basic isometries. Okay? And then you got 5 minutes. If I run over 3 minutes, is that going to be all right?
Oh, that's fine.
Okay. Here's a task that I don't think we'll finish, but can you, let's see, if we go to, can you go to Adobe Connect?
Right
The
now,
Friday,
sure.
can you do that easily, or is that going to take a while?
I have my laptop here.
Okay. So if you go to the Friday room for Adobe Connect, then I can make you a presenter and you can share your screen. Actually, wait a minute. Can you share your screen in BlueJeans?
I'm not on
No,
my
I don't think so.
computer.
Actually, I think you have to do it in Adobe Connect.
I'm through a Polycom system at my school.
And I wonder if that's just. You know what? Okay, it's going to take too long. I have to figure that out for next time. Let me just tell you the task. All right.
Okay.
And I think I'll put this in the homework. But I'll show you an example. So let's make a new window. So you can see my screen?
Yes.
Okay. So I'm going to geometry here. Here's the challenge. I have a point. and I'm going to make a line. Okay.
Uh-huh.
Hello. Okay. And the challenge is I want to reflect this point. I want to reflect point A in this line without using the reflection tool, without using any of these transformations, so no reflection tool. Okay?
Mm-hmm.
How would I do that? I'll let you think about it for a minute.
You could draw a perpendicular line from A
Okay. Okay.
to the
So we'll go up here, perpendicular line, and it says select point and then the line. So go back. Gotta click. Okay. Point, line. All right, got that.
And
Now what?
then I think you can set point B as the intersection between those two lines.
Sure. But let's just do this. There. Okay, got that.
And then you can measure the distance between point A and B.
Okay. So here. Okay.
And then um, you can draw point C on the other side of the line such that the length DC is also 4.71.
Okay. So I'm going to make a point on this line. I see. So you're saying make a point on this line like this, right? And
Yes.
then
Uh-huh.
measure this distance.
Yes.
Okay.
Can you set the
So
distance somehow?
yeah, right here.
Yes.
Okay.
Could you change the distance of that line then by like right clicking?
Uh, right click on what? E?
Um, right click on DE, the line DE,
Oh, on
the
the
segment
segment.
DE.
I haven't drawn the
Yeah.
segment yet. This
Oh,
is only a
okay.
line. I can draw the
Okay.
segment and then right click
Yeah,
on it.
draw the segment.
Okay. So we go down here.
And then can you right click on the segment and
I
then go
did.
to object properties?
Okay.
And then is there a way to change the distance of it through object properties?
I'm not sure.
Oh,
Let's look here. I don't think so.
oh, 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 I see. Okay. Okay, that was a bad idea. You can get rid of
Okay.
point E. I got a new idea.
Okay.
You can draw a circle centered at D and where it
Ah,
hits A.
okay.
Yeah. Yeah, and then where the other side of the circle hits the line, that's your reflecting point. You don't need to do any of the
That that
distances.
that's a
That
better
was
idea.
Yeah, that's a much better idea.
That is a better idea. Good for you. Okay. So the obvious next question is, and so what this does, the purpose of doing this is to define reflection of a point.
Uh-huh.
Okay. So
Okay.
point A, let's label this.
Right.
And I
Lou,
think
may I just interject real
sure.
quick and say we need to be mindful of Walter's time.
Right. Okay. I'll stop. Okay. So that's the purpose of this is to define reflection. All right. So I'll put in the homework to do something similar for rotation and translation.
All
Okay.
right. Okay,
All
cool.
right. I am mindful of your time. I have been reminded.
It's all
Okay,
right.
Walter. Have a
Yeah.
nice weekend,
You too.
and I'll see you on Tuesday.
Yep. All right. Bye.
Take care.
Yeah.
Do you need anything from me, Lou? Is it going pretty
no,
well?
Except I mean, in a way, it's okay, but I